Okay, well, thank you guys for joining this sixth class. So I just want to announce that so we have three more classes, including this one. So there's this class, there's the class next Monday, and then there's the final class will be on August 7th. Um, so that's what our schedule is looking like. So I suppose we can just get started. All right. So to give a bit of a refresher from last class, we were talking about, well, Python classes. Um, so can so can anyone tell me in their own words what a Python class is? Well, I can say what a class is in my own words. So a Python class is pretty much a way to, or rather, a Python class is kind of like a blueprint for objects. And now the next natural question is, what is an object? Well, a Python object is a way to how can I explain what an object is? It, it's it's a way to symbolize a real world object in code. That's essentially what a Python object is. Um, so yeah. So from last class we left off with an exercise where we were supposed to create a class teacher with the name, subject, and grade as the required fields. This class has three extra methods: get name that will return the teacher's name, get subject, and get grade. Um, okay, so in this exercise, we see words like fields and methods. Does anyone remember what the difference between a field and a method is for a class? We talked about this a lot from last class, what fields are and what a method is. All right. The main thing I want you guys to take away from uh, the fields and methods in a class is that I want you to associate fields with variables because we all know what variables are. And I want you guys to associate methods with functions because we all know what functions are. So fields are essentially variables, but for a class, and methods are essentially functions, but for a class. So that's how we know what the difference between a field and a method is and what they are. So let's go with the exercise. So from last class, we created all these fields and methods. So we have fields for the name, subject, and grade of the teacher. And we have methods for returning the name, subject, and grade for the teacher. And then here we instantiated a teacher object. So now our next step is to print out the name, subject, and grade of our teacher object. So here is an example of how we can print out the name of our teacher objects. So we do T1 dot, where really what we're going to do is call the function. So to get the name of our teacher object, we can do T1 dot get name. So this dot get name syntax means that we're going to call the get name method of the teacher class. All right. Does that make sense to everybody? So if I were to run this, we get the name of our teacher down here, which we already set when we instantiated the class. So now I have a question for you guys. How can we print out the subject and the grade of our teacher? We know how to print out the name of our teacher, but how do we get the subject and the grade? Okay, well, it has to, so to get the subject of our teacher, we have to use this get subjects method here in some way. So we use it by doing um, T1 dot get subjects. That's how we get the subjects of our teacher. And we get the grade of our teacher by doing get one dot get grade. Okay. So by running all this, we get um, the name, subject, and grade of our teacher. Does anyone have any questions about that? About calling methods from a class? All right. Well, let's continue on with the lesson then. Okay, we have a quiz. Which of the following represents a template, blueprint, or contract that defines objects of the same type? Okay, so the answers can be a class, an object, a method, or a data field. So I'll give you guys a minute to think about this question and come up with an answer. All right, the correct answer is A. Very good job, guys. So a class is a template or a blueprint that defines how objects can be created. Right, next. Which of the following keywords mark the beginning of a class definition? We have def, return, class, or all of the above. I'll let you guys think about this for a second. Right, the correct answer is C, class. So very good. I'm glad that we got that one. Okay, so this tells me that you guys are taking something away from the lessons. Uh, so that's good. So yes, the class keyword marks the beginning of a class definition. Okay, now we have this. What will be the output of the following code snippet? So I'll let you guys look at this code snippet for a minute and then come up with an answer. Yeah. Well, the correct answer should actually be C, though let's check it together. It should print out 123. But yeah, let's check the answer together. Yeah, it is 123. Yep. So this code snippet prints out 123 because we're declaring a sales object with an ID of 123. So self.id over here becomes 123. And then when we call val.id, it goes to the ID that we set when we instantiated the objects and yeah, that's why it's 123. Any questions about this quiz? Yes, Henry?
Then what about the ID equals 100?
Yeah, that actually does nothing. Because if it was self the ID is equal to 100, that would do something. That would make the ID equal to 100. But because there's no self.id there, it actually doesn't end up doing anything. So it's not used. So that line is kind of a trick there. Yeah. Hope that answers that question. Okay, moving on. Now you see that we can use the name of the object and then use dot to get the method or property of the class. Please pause and think about our string and list, type in these and wait for the pop-up. Oh, interesting. Um, we'll see what the slide's trying to get at here. Okay. All right, let's play around with this. Um, so you have my strings equal to, okay. So we have a really neat little function, a little capability of our IDE here. Um, so what I've done is first I've created a variable called myString that is a string, and then I did myString dot. And what myString dot does is that it shows me all the methods that I can call on this string object. Some examples are capitalize, count, join, find, format. So these are all examples of methods for the string objects. Okay. And we could do the same exact thing for a list object. So if we have a list like this, and then we do dots, we can we can see all the methods and attributes of a list of a list object. Things like sort and pop and copy, clear. Um, so yeah, strings and lists are objects like all the other objects that we've been creating as practice so far. So so lists and string objects also have fields and methods of their own that we can play around with. Uh, so yeah, you will see a list of attributes and methods popping up for you to choose. Now you understand that string or list, which we learned a while ago, are actually objects and classes. That is why Python is an object-oriented programming language. All right, now we have homework. Think about a real world object, for example, a car. Please create a class with at least three attributes and three methods for this class. Okay, does this homework assignment make sense to everyone? We know what attributes and methods are. Attributes are another word for field, and we know what methods are, and we're trying to create a car class. So that is our homework assignment for this week. Um, so yeah, I will post this and then we will move on to the next lesson. I'm just posting the assignment right now, and then we'll move on to the next lesson. Oh yeah, I'm pausing my screen right now because I'm posting the assignment. Um, okay. All right. Now we are in the slides for class 13. I think this is actually six, maybe class six or something. Anyway, so we have some review questions. Can anyone tell me what a recursive function is? What a basic definition of a recursive function is? Okay, so a recursive function is a function that calls itself. That is the main thing I want you to get out of recursive functions. They are simply functions that call themselves. Okay. Can anyone tell me what a class constructor is? Okay, so a class constructor is that init method um that we worked with last class. So an init method or a class constructor is a method in a class that describes how an object is created. So looking back in our teacher example, this function right here is the constructor because it has this underscore underscore in it name, which in Python is how a class is created. Um, and yeah, so this is what a class constructor is. So any questions about this review? No, all right. So a class. Uh, a nested or inner class is contained within another class. This is one example of encapsulation where the inner class is not useful by itself. It cannot be used outside of the outer class. So kind of like how with functions we can have an inner function and an outer function. Um, there's the same exact thing with classes. With a class, we can have nested classes where there's an outer class and an inner class. So in Python, an inner class is a distinct entity in that it does not automatically get access to the outer class members in any special way. What does that mean? Well, it means that for an inner class, it doesn't have access to all of the stuff that an outer class has. So both an inner and outer class can have members, and by members we mean fields and methods. So an inner class doesn't have access to all of the fields and methods of an outer class. So here we have an example of a nested class. So let's take a look at this. Yeah. So in this class, I'll ask you guys. Can anyone tell me what the inner and outer classes of this class here are? So we have class head and class human. Can someone tell me what the inner class is? All right, so the inner class in this example is head because it's inside the outer class, which is human. So human is the outer class, head is the inner class. So notice how for class human, we have a constructor with this init method. And then after the constructor, we have another class definition called head. Um, and then I'll ask you guys, so in the class head right here, in the class head, what is the name of its method? What method is in the class head? Okay, so the method called talk is the method in our head class. Okay. Um, so yep, the method called talk. So we call rather we create a human object with this line here. then we print out the name of the human object. And then with this syntax here, we take our human object that we called Guido, and then we did dot head to access the head class. And then we did dot talk to actually use the talk method in the head class. Okay. Does this syntax make sense to everybody? Are there any questions about it? All right. So advantages of inner classes, logical grouping of classes. If a class is useful to only one other class, then it is logical to embed it in that class and keep the two together. Nesting such helper classes makes their package much more streamlined. So if we have a class called human, it doesn't make sense to have a separate class called head because, well, um, maybe because humans have heads. So it would make more sense to have an inner class for an inner class called head for the human class. So the human class would be the outer class and the head class would be the inner class. That's one advantage of inner classes. Another example is increased encapsulation. Consider two top-level classes A and B, where B needs access to members of A that would otherwise be declared private. By hiding class B within class A, A's members can be declared private and B can access them. And in addition, B itself can be hidden from the outside world. Uh, so so this is an example of encapsulation. Encapsulation is a pretty important topic in object-oriented programming. Encapsulation makes it so that the programmer only has access to the things that they need. Um, so so going back to our human example, um, the programmer wouldn't really need, or rather, the head class wouldn't really need to have access to all the other possible subclasses of the human class. So with encapsulation, with inner classes, we can make sure that that certain classes only have access to the things that they need. So that's what the slide is talking about. We have more advantages of inner classes. They yield more readable and maintainable code. Nesting small classes within top level classes places the code closer to where it is used. The main advantage is organization. Anything that can be accomplished with inner classes can be accomplished without them. So the main advantage of inner classes here is organization. What is this? That, oh. Okay. Any questions about the advantages of inner classes? All right, moving on. So instead of starting from scratch, you can create a class by deriving it from a pre-existing class by listing the parent class in parentheses after the class name. A child class inherits the attributes of its parent class, and you could use those attributes as if they were defined in the child class. A child class can also override data members and methods from the parent. So far we've been talking about inner and outer classes. Well, we in this slide we're introducing a similar kind of topic called inheritance, where you have a parent class and a child class. So inheritance allows us to define a class that inherits all the methods and properties from another class. Parent class is the class being inherited from, also called the base class. A child class is a class that inherits from another class, also called the derived class. So here we have an example of a parent and child classes. Oops. Okay, so oh, that's interesting. Okay. So in this code, we have a class called parent and another class called child. Now, this isn't a nested class because the child class isn't inside of the parent class, it's outside of it. But the main difference comes from this line here where we declare our child class. Um, so here in parentheses, when we declare our class, we have the word parents in parentheses. So that tells Python that the child class is inherited from the parent class up here. So if we run this program, oh, okay, yeah, we need to. Oh, I see. We have to add some parentheses here because, yep. Um, okay. Um, so in this example, the parent is the parent class and the child is the child class. So we talked about parent and child classes. Another example of a real world, I guess, thing that can be described as a parent and child class in Python would be if our parent class is, say, vehicle and our child class is truck. See, now that would be an example of inheritance because all trucks are vehicles, okay? So if we have a vehicle class that has some fields and attributes, some fields and methods. The truck class, which is a subclass of the vehicle class, would have access to all of the fields and methods of the truck class. Um, so that's one example. Can anyone else think of an example of a natural example of a parent and child class that could be a thing in Python? So one example I gave was vehicle and truck. Does anyone have any other examples? All right. Another example is a book class and uh actually no, I won't go there. Actually, yeah. So one example is a book class and a Harry Potter class, let's say. So Harry Potter, it would be a subclass of book all Harry Potter because all of Harry Potter books are books, right? So if we have a book class that has some methods and some fields, our Harry Potter subclass would have access to all those methods and fields. So the main thing I'm trying to get across here is that um, is that we can like have base classes and derived classes, or parent classes and child classes, where the child classes has access to everything that the parent class does, but not the other way around. All right, so now let's try creating an instance of the child and parent. So let's do that down here. So we could have ex1 is equal to parents. Let's see if it takes any, okay. And we have ex2 is equal to child. And we could do ex1 dot parent method. And we could do ex2 dot parent method. Let's run this. Okay. Okay, so in this code, I created a parent object and a child object. And then for both ex1 and ex2, I ran parent method. So one thing that I really want you guys to understand is that in the parent method, um, which for ex2 is a child is an instance of the child class. Uh, but even though it's an instance of the child class, I was still able to run parent method, which is a method in the parent class. And I was able to do that because uh, I was able to do that because a child class has access to all the methods of its parent class. That's why I was able to call a parent method from the child class. Does that make sense to everybody? Yeah, I know that this material might be kind of hard to digest for the first time. So that might be why not much people are saying anything. But yeah, classes and objects and inheritance is always a hard topic, even for undergraduates in college. So don't be discouraged if you don't understand things completely quickly. So what do you guys, I have a question for you guys. What do you guys think will happen if I call a child method from the parent class? Let's say that I do ex1 dot child method. So child method is a method from our child class, and ex1 is a parent object. What do you guys think will happen if I try to run this method? Yes, Henry?
Would it be something like invalid or?
Yeah, it'll give an error. Yep, it'll give an error because it'll say that the parent object has no attribute child method. So, um, so another important thing to remember is that we cannot run, um, so given a parent object or a parent class, we cannot run methods from its children. But given a child method, given a child class, we can run methods of its parent. Okay. That's why in EX2, which is a child object, I was able to run the parent method. All right. Okay, let's move on. You can override the method in the parent by redefining it in the child, just like the behavior of init. in the child, which now does things differently from its parents. So we can show an example. Actually, we already did show the example. So in our code, we see that that the parent method has that the parent class has a constructor, and we can see that the child class also has a constructor. So one question is call the when we create the child method, which constructor does it listen to? Well, it listens to the one that's for the child class. So when we create two methods with the same name in the parent and child class, that's called overriding a method. So we have some new terminology here. Overriding a method. So overriding means is essentially when when a child class has the same name as a method in its parent class. All right. Does anyone have any questions about what we've gone over so far? All right. Let's move on. You can add new properties and methods to the child. The parent class will have no visibility of the change in the child. On the contrary side, the child will inherit any changes that the parent has. So we've seen some examples of this already. When you have a child class, you can add methods and fields to it that the parent can't see. But in the parent, if we add methods and fields to it, the child will inherit all of the changes that the parent made. So okay, so now we have a new function. So when we call super opening and closing parentheses, uh, that returns a proxy object or a temporary object of the superclass that allows us to access methods of the base or parent class. So we have an example here. Whoops. Maybe I shouldn't copy this in. Um, so let's say that we have a class called dog. Actually, I'll ask you guys. I'll ask you guys. What class is dog inheriting from? Can someone please tell me what class that dog is inheriting from? Yes, Henry?
Canidae family.
Yep, very good. Yep, it's inheriting from the Canidae family, and we could tell because it's in parentheses here inside the dog class. So we can see how it has a constructor, it has a print statement, and then down here we have super. Um, we have super.init dog. So what super does is that it allows us to just use the constructor or use the base or use a method from our parent class. That's what super does. So what this line here means is that we're just going to call the init function for for um the init function for the Canidae family class. I will just run it. So yeah. Okay, now we have a quiz. Which of the following can be used to invoke the init method in B from A, where A is a subclass of B? All right, so the correct answer is A. And it's possible that C might also work too, but the correct answer is A. So A is how we can call or how we can invoke the init method in B from A, where A is a subclass of B. Hmm. Okay. A class in Python can have multiple parent classes. All methods and properties of all parents will be inherited. If the parents have a property or method of the same name and a child does not define its own, then the one from the parent which appear before the others will take the order. Uh, so it's possible for a class in Python to have multiple parents. So here's an example of this. We have a class dog. Can anyone tell me what classes that dog is inheriting from? Yes, Henry?
Non-marine mammal, non-wing mammal.
Yep, very good, Henry, and also very good, Audrey. So those are the classes that dog is inheriting from. So it's possible, so in Python, it's possible to inherit from more than one class. Funnily enough, in Java does not allow this. Java does not allow multi-class inheritance, um, but Python does. Okay. So let's see. I kind of want to avoid getting into more advanced stuff, but we still have 10 minutes to go. So um, I guess we can just practice with creating our own classes for a bit, just to make sure that we all have an understanding. So, so let's all right, so let's play around with this for a little bit. Let's say that we have a class called animal, okay? And our class animal has an init method where we print where we take the name of the animal. Actually, I'll ask you guys. So what are some fields or attributes of an animal? Yes, Henry?
Lungs/gills.
Hmm. Okay. Um, maybe let's think even more general than that. So like let's say all animals have names, all animals have colors, um, all animals have, I don't know, What else do all animals have? Hmm. I guess we'll just stick with two for now. So we can make self.name is equal to name, self.color is equal to color. And we get name, self, return self.name. Unless we're just creating some methods for our animal class. Okay. Um, so now let's create a class that inherits from animal. Can anyone give me an example of their favorite animal that we can use as our example for a subclass? Any example of an animal? Uh, Goldfish. Okay, yeah, goldfish works. So now we have class goldfish. So goldfish inherits from animal. So that's why we put animal in parentheses there. Um, so we can create an init method. Okay, so now I have a question for you guys. How can we make it so that our goldfish class calls the init method from animal? What syntax do we use? Or what keyword do we use to make our goldfish class um, call the init method from our animal class? Oh, that's because it's a typo. Thanks for catching that. Should be in it. Thank you. Whoops. Should be in it. So the way that we can call the init method from animals with super. Okay, we do super dot init. Um, I think I need to. Do I need to add anything else here? Let's see. Uh, hmm, yep. So yeah. So we do super dot init. Um, okay, and we know that goldfish has all the methods that the animal class does. So an attribute that goldfish have could be, I don't know, uh, gill number for the number of gills that it has. We can also do fin number, how many fins that it has. So let's try creating an instance of our animal and goldfish class. Goldfish is equal to goldfish. Let's see, let's say 4 and 4. Will this run? Uh, color, color, self dot go number, go number. So, okay, so now let's try to run this now. Let's see what we get. No. Oh, because I forgot to do this. Um, so let's name our goldfish um, Ted. Let's make the color of a goldfish gold. And let's say that Ted has 4 gills and 4 fins. So writing this gave no errors. Yay. Um, so now we can do something like goldfish dots get name, which is in the parent function to get the name of our goldfish, which should print out Ted. So yep, that all works. So here's an example of a parent class and subclass that we created together. We created an animal class that's a parent class. It has an init method, a get name, and a get color. And then we also have a goldfish class that overrides the init method in our animal class. And we use super to call the init method from the parent class, and then we got some stuff from our goldfish class. Does anyone have any questions about this code? All right, we went through a lot of material today. Um, so next week we'll start with some more advanced material, so you guys prepare for that. And I really advise that you guys do the homework for this week because it'll really help you prepare for this class for the next class. Um, and yeah, that's about all I have for today. It's about 7:30 now, so if there are no questions, I will wish you guys best of luck for this week and yeah.